Hello everyone, this is Sean Parvini. In this video, I'm going to try to derive the general formula for finding the clock angle, the measure of the central angle, that is formed by the two hands, the minute hand and the hour hand, in an analog clock. So we're going to have two parts for this. Part one is where the region or the angle, whichever you look at it, does not include or contain the 12 o'clock position. The 12 o'clock is the key in deriving the general formula here. So we're going to look at part one where the region does not contain 12 o'clock position, and then part two will be a simple extension of our findings from part one, where we give you a formula for the region or the angle that contains the 12 o'clock position. Now, in another video that I did, I found the measure of the central angle that is formed at 4:42 between the minute and the hour hand. So I'm just going to stay with that one for now, but then remember, this is the general derivation of the formula. So what we need to do again is to recall a couple of questions we answered earlier. How many degrees are there in a minute? So if we take a look at degrees in a minute, there are 360 degrees in a circle. So if we divide that by 60 minutes again, that's going to give me about 6 degrees per minute. So that means every minute, the minute hand spans 6 degrees on the surface of the clock. And the other question is, how many degrees are there in 1 hour? Again, if the total number of degrees in a circle are 360 degrees divided into 12 equal portions, then that will give me exactly 30 degrees per hour. So again, that's the measure of the degree that is spanned by the hour hand every hour. Okay. So let's say at 4:42. Now notation. Here I'm going to call h the hour part of time and little m for the minute part. So h is 4, the minute is 42 in my example. Okay. So, and therefore little m here is the minutes that the angle, the minute hand makes with 12 o'clock. Okay. Again, it is the angle that is spanned by the minute hand. So if I look at, like, in general, how many minutes, how many degrees the angle has spanned in capital M minutes. So M would be 6 times little m. And what do I mean by that? Let me try to paste here my clock and I'll show you what I mean. Okay, so suppose I'm just looking at the minute hand here. Okay, this is my reference 0, and suppose the minute hand goes here. Okay, only the minute hand. So this is the measure of angle capital M that I'm looking at. Okay, so it's going to be 6 degrees per minute, right? So at any time minutes past the hour, little m, the measure of the angle is 6m, and that is in degrees. Okay, so that's the easy part. So to give you an example, let's say at 42 minutes past the hour, 42 minutes past the hour, the measure of the angle that is traveled by the minute hand is 42 times 6 degrees per minute, or it has traveled 252 degrees. So that's what this number is going to be. Okay. Now it's easy to determine how far the measure of the angle is for the minute hand, because in reference to 12 o'clock or 0 minutes here, it's fairly straightforward. You just count the number of minutes times degrees per minute. Okay. Now, let's answer the more challenging question is how far has the hour hand moved from 12 o'clock. Okay, so let's take a look at this one now. And for this work now, I'm gonna take a look at, let's say, at 4:42. So I'm looking at, this is the hour hand. That's where it's gonna be. Remember, it's not gonna be at 4 because everything is moving. So 42 minutes into the hour hand actually have moved away from 4 o'clock now. So how far has it traveled with respect to 12 o'clock? Remember, everything is measured with respect to 12 o'clock. Well, the number of whole hours here, 1, 2, 3, we know that each of those span 30 degrees, 30 degrees, 30 degrees. So it's going to be 90 degrees as the hour hand moves from 12 o'clock to 3 o'clock. Now, when it moves to 4 o'clock, we add another 30 degrees here. So far we have 4 times 30 degrees, right? We're going to need that for our generalizations. Now, the question is this portion, right? And for that portion of it, again, like I've done in my other videos, if you look at that portion, so let's say this is 4 and this would be 5, and my hour hand is somewhere in here. So if I extend that, this is how far it has traveled, right, away from 4 o'clock. Now this angle, measure of that angle, we're going to call it x. Okay, so how am I going to find x? Well, it's easy to find x here. X is going to be, remember, in 42 minutes past the hour, x is going to have 42 out of 60, right, share of that 30-degree angle that spans between 4 and 5 o'clock. So 42 minutes out of 62 minutes. Again, that's the percentage of the angle that is spanned by the hour hand, and that's the share of 30 degrees because there's only 1 hour from 4 to 5 which covers 30 degrees. And that's going to be 21 degrees for our specific example. Now, in general, if I take a look at the measure of the angle that the hour hand has traveled, I'm going to call that capital H. Okay, so this is going to be capital H is the measure of that angle. So in general, therefore, capital H is how far the hour hand has traveled, has moved away from 12 o'clock. It's going to be 30, because it's 30 degrees per hour, times number of whole hours plus x. X is the portion, again, the part of the hour due to the minute hand. So there you go. That's what that is. Okay. And let's call this part 30h degrees. All right. So that's the general formula for how far the hour hand has moved. So at 4:42, therefore, at 4:42, this is what we have. We know the minute hand, M, has moved, we mentioned 252 degrees, right? The hour hand has moved how far? It has moved 30 times 4 plus 21 degrees. That's 141 degrees, right? Therefore, the angle theta, which is actually what we want to find, angle theta would be this angle, the angle the clock hands make together. So the angle theta is going to be the difference between M and H, right? 252 degrees minus 141 degrees, or 111 degrees. Now in my other video I derived this in a different fashion, but the answers actually match with what I had before. So there you go, that's the measure of the angle. Now our focus, remember, is in finding the general formula, right? Therefore, for my general formula, so here's how I can do my general formula now. So if I draw a circle here that represents the clock, and suppose this is the measure of angle H. Okay, now this would be in red. This is the hour hand, and let me use a different color. I'm going to call this part, this is the minute hand. Okay, and of course this region is what measure of angle theta is. So I can actually write that theta is here is equal to, I'm going to take the absolute value of the distance, the measure of angle H, or the that's how far angle H has traveled from 12 o'clock. Everything, remember, is with respect to 12 o'clock. H minus how far M has traveled. So as far as my graph goes, I can also show you this. Call this, there you go. This is what M is. And if I subtract, this is what H is, right? If I subtract H from it, and this is for H hours, then I'm going to get what's in here, right? By superpositioning, I'm going to get the measure of the angle. There you go. That's what theta is. So that's what that's why that formula works. And again, I need the absolute value of it because you can measure the angle from minute to hour hand or from hour to minute hand. We don't care about direction, we just want the measure of the angle. So now let's generalize again our findings here. H, I have H up here. H is going to be what? 30H, little h that is, plus X. Oh, and we need to generalize X, by the way. In general, X is going to be whatever the minute is, right? Whatever the minute portion of your time is divided by 60 minutes. This will give you the percentage of that 30 degrees. That's in the 1 hour. Okay, so that's going to be 1/2 M. And I'm going to add now, so M, let's see, H was 30H plus X, but X is 1/2 M. Subtract big M, remember big M was 6 times little m, that's from up here, right? From up there. And then I can do simple arithmetic here. This is going to give me absolute value of 30H minus 11/2 M, because you have 6, take away a half from 6, you get 5/2, right? I mean 5 1/2, which is 11/2 M. And if I get LCD, I can write this as 60H minus 11M divided by 2. That's the least common denominator. And I can bring out the 1/2. And that would be 60H minus 11M. So there you go. That's the measure of angle theta. That's the general formula. Now remember, this formula works if angle theta here, angle theta, this one, it does not contain 12 o'clock. And you can see from my region, 12 o'clock is up here. It's not inside of that reshaded region spanned by theta. So let's try it. Let's try our example. Let's say at 4:42. the measure of angle theta is going to be 1/2. Remember, at 4:42 the hour portion, little h, is 4, and the minute portion, little m, is going to be 42. So our formula is going to be 60 times h is 4, and then minus 11 times m is 42. Okay, and this is going to give me 1/2 times absolute value of 240 minus 11 times 42. Let's see, 10 times 42 is 420, and then another 42 is 462. Not using a calculator, as you can tell. Okay, and that number is going to be 222 negative. You see that? That's the need for absolute value. That's why we need it, because the measure of the angle is positive. And that's the answer we had up here, right? 111 degrees. So the formula works. Let's take a look at another example. What about, let's say at, I don't know, 220. Let's take a look at that, another example. So at 220, we want to know the measure of the angle between the hour and the minute hand. Here's the hour, here's the minute. Okay, so theta is 1/2 the absolute value of 60 times 2 minus 11 times 20 equals. Okay, and we can actually complete this. Now this is going to be 1/2 absolute value of 120 minus 220, and that's going to be, absolute value is going to be 100. The measure of the angle is going to be 50 degrees, and there you have it. Now what if the region actually included 12 o'clock? So if 12 o'clock is included, so for instance, let's say I have something like this, where this is the hour, this is the minute hand. This is the measure of angle theta now we're seeking. So to find, in terms of a region, a shaded region, let's say this is the region that I want, I can actually think of this as the full circle, which measures 360 degrees. And then we're going to subtract from this circle the part that lies below what we are looking at. Let me redraw this one. And this is the part. So that's angle theta. And this is the part that we're actually going to subtract out from it. Sorry. There you go. And that's going to give us the desired region, which includes angle theta. So this is going to be 360 degrees. And remember, the region that's between, that doesn't include 12 o'clock, that's below theta here, is going to be 1/2 the absolute value of 60h minus 11m. And that is going to be the formula for angle theta. Again, this assumes that 12 o'clock is contained in the region. And what I mean by that again is this. See, here's 12 o'clock. It is in that region. Okay, now let's take a look at an example of this one. Alright, so suppose we want to know the measure of the angle between the hands of the clock at 11:15. So here's my hours, here's a minute. Therefore, the measure of angle theta is going to be 360 degrees minus 1/2 absolute value of 60 times 11 minus 11 times 15. Those are the minute part of the time. That's going to be 360 minus 1/2 absolute value of 660 minus 165, and this will give me 360 minus, inside the absolute value I got it to be 495, and this is going to make it 360 less 247.5 degrees for 112.5 degrees. And there you go. See how quickly now, without drawing the clocks and going through all the details, we can do this if we have a formula. But then again, your instructor may actually want to see how you come up with the measure of the angle from scratch, not just using a formula. Alright, and with that we are done with this video. I hope you find this useful, and thank you for your attention, and good luck to you.